I'm going to check that it's really starting on YouTube just to make sure. Okay, we are live actually. So hey guys, hi everyone. Welcome to this live training, allegorithmic live training that we do today with Bjorn, who is here. We have Cesar from Mexico, Kyle, Marcelo, Nicola from Serbia, if I'm not wrong, and myself, I am Vincent and, from Allegorithmic and from Barcelona. So today we are here to speak about the pixel processor node. So I think you have seen my face enough. So right now what I'm going to do is share my screen. Like that. Okay, so everyone should see my screen now. So what we're going to do today is speak about the pixel processor node, which is a node that has been introduced. I'm going to make one here, pixel spacebar, in case you don't know, to get this. So the pixel processor node is a node that has been introduced in Substance Designer 5, and which is an extremely powerful node, as it allows the user to actually control each pixel of a bitmap individually, at least for of the pixel processor. So you can do tons of stuff with that. Sorry, I'm going just to make something more that you cannot see, just to prepare myself, because I made some notes in order not to forget anything. So I'm going to do that as well. So yeah, as I say, it's a node that has been, which is extremely powerful because you can control each pixel one by one, and this is extremely useful, especially if you want to create some filters, so some filters to distort image, to change color of inputs according to properties you define. But it's true that it's not the most self-explanative node. So today, what we're going to do is to see and to start from zero. I assume that you know how to use Substance Designer, but I assume that you don't know the pixel processor node, and once you have seen it, and maybe open it, you have said, "Oh my God, it's not for me." So I hope after this hour and a half, you will get a better understanding. By the way, there is a chat for people who are who watch on YouTube. If you want to ask questions, it's better to go to the link below. There is a link to the Hangout, and from there you can ask the direct question to the chat. I'm going at the same time maybe to open. I'm going to open YouTube just to make sure in case people are asking questions. So let's see that. And there is the YouTube link somewhere. Okay, I'll see that later. Give me 2 seconds. Community event introduction to pixel processor. If you're on the link, you have the link on the right, and YouTube. Okay, I'm just checking that there is no problem on YouTube. Okay, it works, and so far I don't think there is any comment. Perfect. So please, if you have comments, leave it on the Hangout. So let's start. So the first thing that we want to watch right now is some example of what you can do with the pixel processor node. So I have this node here, but I'm going to delete it right now. We don't need it. And here is some example that I did for you to show what you can do. So for example, one node that I made is a squash node that is basically, here it's a graph instance, but inside it's based on a pixel processor. And it allows, for example, to take one input and to distort it according to other inputs. So for example, I can define a distortion on the X intensity, Y intensity. So for example, we start with this, and we can just distort the like that, just by moving this parameter. You see that it makes some crazy stuff. I won't explain how it works today. I made it actually in the tutorial. But I can show you that you can obtain crazy results, and this is really based, if I open the reference, open, yes, you see that everything is based on a pixel processor. So extremely powerful. Another one that I want to show you, which is more self-explanative, is, for example, here, it's you have a normal map, and something really difficult to do with a normal map. I try to, there is some button that I cannot touch like that, is to rotate it. So here what I did is VG node turn normals, and when you rotate the node, sorry, I just want to deactivate that, but there is a button that restrains me to do it. Okay, like that. Okay, so right now with this parameter, you see I add a parameter, and if you use it, you see that the color is changing with the rotation, which means that the normal map is always available. Once again, it's a tutorial I made, which is available on my personal channel on YouTube, and this is one of the node that I prefer because, as you may know, rotating a normal map is extremely painful, and with that it's automatic, so it works pretty well. Another one that I did is, for example, fine edge detect. So it's, as its name says, it allows you to take an input and to detect the edges and to put and to shine them. It's more. It's finer than the one you have in Substance Designer, but it's limited to 1 pixel in this version of diameter. So you see you have some parameters that I added. So these are just examples that you can use. Of course, I'm just going to plug that. So just to see the normal map that it could give, the first one. So this is just example, and today we are going to start from scratch and to do another one that I call the kaleidoscope, which is this cat. I hope you, and we are going to slice this cat in some parts. Basically, it's a node that will just make this effect, meaning like, sorry for that, I may have some. So it allows you to really do a kaleidoscope effect with one input, and that's what we're going to do today. So I hope it can be useful for some people. I think it can be if you want to make some patterns or tiles or whatever. But it's really a pretext to make a tutorial with you guys. So before to start, do you guys have any question? Or is it fine for everyone so far? Cool, it seems to be fine. So before to start, you need to have a cat image or whatever square image you could find that is useful. I invite you guys to share your screen as well on the for people who are on Hangout. You have a button, a green button in the top left of your screen, so we can see what I can see what you are doing. So, for example, Kyle is watching me right now, and so yeah, it will be more interesting that sharing our face. This is me. Kyle is here. Oh, Kyle has a wonderful cat, I think. Yeah, awesome cat. If it's a dog, if it's something else, it doesn't matter, of course. The best is, of course, a power of 2 size image. Oops. So let's start and let's make a new graph. I won't cheat, I'm going to do it with you. So first, I do Control M. Actually, I'm going to launch something in order to let you see the shortcut that I use. Like that. Okay, so it should be fine. Start. Okay, so this is just something that will show what I'm doing. So first of all, okay. So first of all, I'm going to create an empty graph. And for this exercise, I am going to use an absolute value. 124 should be more than enough. What you want to do after this, relative to parent, we don't care so far. And let's create a new one. So as you can see, it's empty. I'm going to change a bit my interface so you see stuff better. So I'm going to remove my library that I don't need. I'm going to move. I'm going to close my 3D view because we'll mostly work in the 2D view, and I'm going to place this below here. So I maximize the space for you to see what I'm doing. Okay, so let's do like this. Let's play with this cat a bit. So first thing I'm going to do is in my resource, I'm going to take my cat victim and place it here. So as you see, it creates a bitmap. The size is 124, perfect. So first thing I do is press spacebar. As you can see, as soon as I use the keyboard, it will write what I do. And I will type pixel processor to make it appear. And then I'm going to plug this. So first of all, I'm going to explain what we have with the pixel processor node. So as you can see in the pixel processor node, first you have inputs. And they are dynamic. I can put as much as I want. If I put, let's say I put the same, for example, you see that you always have space to add another one. So let's do like this. And then you have an output, of course. You can define it color or grayscale depending of your need, obviously. In our case, as we want to distort the color image, I leave it in color. And then you can enter into the pixel processor by doing edit. And this is where you may have been scared a bit, not knowing what you have to do, how it works, and etc., etc. This is quite normal. So before, as I explained you, the pixel processor is processing each pixel one by one, not in a random order, it's parallel in general. So if you want to make it clear, what I can write, and it can be a good, here I type comment, because I'm going to add a comment, which is just for me. You don't need to write it as you wish, but what you can write is for each pixel do that, because that's basically what it does. For each pixel, I don't know if we can resize this, by the way. No, but when you are in a pixel processor node, that's exactly what it does. So for example, here, for each pixel, you have a constant floor, return this value. So you see that here, of course, it's not very interesting because you are just for each pixel defining this color. For example, if I put one, for each pixel, return this color. Of course, this is not super interesting because it's the same. But the fact that you can do for each pixel is interesting. So you can define some stuff which are interesting. And one of the things is it would be nice for each pixel, each pixel to return the position of the pixel. So then you can start working on it. So for example, you can say you can use what we call a built-in variable. So just grab the get float 2, so here, like that. And I don't know if you guys know, but in Substance Designer there is some built-in variables, which mean that variables that are refers to parameters of Substance Designers. So for example, here we have what we call the expose that we're going to do, and the expose, what it does, it returns the position of each pixel. So for each pixel, get me the position of the pixel. That's mostly what it does. And from this, you can do pretty interesting stuff. So for example, you can say, for each pixel, I don't know if I can put that in output, not yet, but I can say, okay, for each pixel, give me the position, and maybe if I do, what we want to return is a color. So what I can say is, right now, is use a sampler node. So what it does, sampler, so I say, oops, sorry, sample color, like that. And this, what it will do, it samples, of course, a color. So for example, here there is nothing to sample, but if I say for each pixel, sample the color at the position of the coordinates, you see that it returns the image. Here, sorry, what I did is, what you can do in a Substance in the function node, because here we are in a function graph, is it doesn't work exactly like the regular graph, because to define the output, you just right-click on the node, and you say set as output node, like that. And of course, it expects a value that is, for example, for a color node, sorry, it expects a float form. So a sample color is perfect. But for example, here I cannot, because it's a get float 2, so it's a float 2, and of course a float 2 cannot be a color because you have 4 channels. Is it? Am I going too fast, or is it okay for now?
It's fine with me.
It's fine for you. I'm just taking a pause just to work if there is some comments. Okay, there is some crash, but it's Chrome. At least it's not Substance Designer, so it's good. It's not that bad, let's say. So yeah, so this node and this node are really important. The getFloat2 with the expose is one of the most important, because what it is for each pixel, return me the position, the coordinates XY of this pixel. And of course, this is really important. But once again, it's not that interesting, because here we have just returned the image, so let's say it's completely useless. But what you can start to do, for example, is to say, you know what, I'm going to make some math before to return. So maybe, let's say I want to make, I don't know, let's say I want to just change the position of on the Y channel. So another one, which is really interesting, is the swizzle node. So if you type swizzle, you see that you have different one, integer and float, 1, 2, 3, 4. So it allows to split a node, to split the channel of the nodes, actually. So for example, here, I want just to isolate the Y channel. So I'm going to use the swizzle float 1, and you see that you can choose X, Y, Z. So in our case, it will be Y, and I will put it here. So what it does is this now just holds the value of the Y channel, and I'm going to do Control V to duplicate. You will see one, and this one will control the X channel. So right now I'm going just to make an example, just to show you how it works. It's not directly useful, because as you will see, it's some stuff that you could do with the transform node, but it's just for you to understand. But soon it will be way more interesting, hopefully. So here, for example, let's say I'm going to make some space like that, and here let's say I want to move on the x-axis. So what I'm going to do is to create a float node like that, which has a value of 0, and I'm going to use an add node like this one. So of course, this one, you have tons of different nodes like this that allows you to do some math. So it's really, if you have a technical background, it's quite easy to understand. If you are, it's not like, it's really as complex as you want it to be. So, but if you do a right click, for example, and you say add node, they are classified by type. So if if you want to have a look, you can say that you have the constant, which allows you to define constants like float, float2, float3, etc. Vectors that allows you to gather some channels together. We'll see that later. Variables, as we use, for example, to catch the S pose, the dollar pose variable, but also maybe one that you want to create. Samplers, we have seen that. Cast is to convert. Operator, it's really straightforward. It's mathematical operation. Logical, we'll see that later. Comparison, it goes to logical. It's just to create some conditions. Sometimes, for example, you say if the value of a pixel is brighter than I don't know, this gray, then do that. We'll see that later. Some function, so don't be scared. I won't go too deep with that. It's free. Once again, I'm going to show you how it works, but then it's you who will decide of the complexity of what you want to do. And control, which is something special that we won't see now. So let's go back to this. So if I plug these two nodes together, what it does is it adds the value. So of course here there is not that much, but what I did here is I separate the value, and what I'm going to do now is to use a vector float2 in order to put them back together. So I'm going to put the x value here. Oops, sorry, it's a swizzle that I use here. So do it again. Vector float2, like that. So I plug the x here and the y here. And now I put that here. And you don't see any change, which is normal. But if you select your float node here, right now you control the y-axis. So you see that right now if you play with this value, you see that your cat is going to move a bit. Which once again doesn't seem that useful this way, but let's be a bit wiser. Let's go back for 2 seconds to our main graph. So it's at the top here. I don't know why it's called _1. Let's call it F2 to rename. Let's call it training. Okay, it's just for me, don't do it. Huh? Okay. So this I said I don't want that. I don't know why it happened. So we are here, and let's say right now that we want to add a noise. So whatever noise, if you have the library, you can choose a node. I will type a noise like this, and I will take. It can be really whatever you want. It doesn't have to be exactly the same, but I will take the creased, which is this one, and I'm going to plug it in the new input here. Okay. Is it fine for everyone? I'm going to wait for Nicolas a bit. Okay. Okay, so leave the cat in input 0 and plug your noise, whatever it is, in input 1. I can see you are scared to use a new noise. And let's go back into the pixel processor right now. You can do at the top with the thumbnails. Let's go back in it. And right now what we're going to do is to say, you know what? I have this I'm tracking for each pixel the position, and what I'm going to do is to use another sampler, but a sample gray this time. Sample gray. And maybe you have seen that below this sample it's written input 0, and of course here you can choose which input. It looks at how many inputs are plugged into the node, and it lets you the choice. So we are going to plug it here. And right now it samples some values. So for each pixel it samples the gray value, but the gray value is also, we can say it's a value, so it goes from black to white, meaning from 0 to 1. So if I replace this, I'm just you have to double click on the pixel processor to see the content, sorry. So right now, if I plug this instead of here we go. You see that it's completely distorted by that. And what you can do as well, if you want to have some control in the effect, you can add a multiplier. So here you see that it's the node here that is distorting your result. Is it clear for everyone? On the y-axis only. It's just each pixel, each gray value for each pixel is adding to the y-axis. That's why we have this. And if you want to have some control, what you can do is to say, I'm going to use a multiplication like that. And I want to control how much this effect will affect the result. So once again, I have to go to the cat here. Ooh. So something is wrong here on my side. You see that it controls, but that's not what we want, because we want to add it after, I think. So maybe what we'll do is change the multiplication and put it here.
Yeah, put so multiplication right after the sample gray, I think.
Yeah, exactly. Exactly, like that. So that's a cool point. If you know Substance Designer, is that you can make mistakes like that, and you can really fix it. So right now, if I play with that, you see that if I put to 0 like that, it doesn't do anything. And if I start moving it, you see that you get your effect, which is cool. And the cool thing is, after, what you can do is you can decide to replace this by a get float. Here, you will see. And expose it. I'm going to show it rapidly. So what you can do is go to your main graph, double click on an empty side, and say, I'm going to create a new parameter really fastly. Do you guys used to use parameters? Or not to create input parameters? Maybe not that much. Okay, so no. Okay, so if you click on your graph, here we are at the graph level. Sorry, I'm gonna remove that. You can create parameters for your graph that, when you create, for example, a substance, are going to be exposed and available for the user. That's the interest. So here, for example, if you click on input parameters here, you just click. Cesar, I didn't lose you. Not yet. And you can give a name, like let's give let's give a name distort amount, which is a name, an identifier for the software, and I'm going just to copy for the label the space. This is the name which is displayed, and this is the internal name. Not really important, but always good to know. So now that you have done that, you have created a float one. You see that you can define the, depending on what you need, but we do need a float one. You go back into your pixel processor node, and here on the get float, you see that in the list there is a distort amount node, and that's what we're going to use. So right now I can plug it here instead of that. I'm going to remove that. And let's see the value. So I go back here. Sorry, you see that we have to switch between graph value and the pixel processor value. You have to do that a lot. So you have to get used to it. But right now, for you, you can put default value to 0. And for the final user, he will have a distort amount that allows him to plug whatever he wants. And of course, you could imagine to replace this by an input, so he can even choose which noise you want. So if I put another noise, black and white spot, for example, you see that the effect will be totally different, like that.
I have a quick question, sorry.
Yeah, go.
Is there a way that you can expose these parameters directly on the pixel processor node, not on the main graph itself?
Not directly. What you can do here, you mean no, you can set a value. For example, you can say, okay, this, but this is something that will be used only, which is really local to the node. Meaning that, for example, if you do the spacebar and I do set like that, you can create a value and call it my value, for example, or whatever. If you want to use it in another part of the pixel processor, which is not really interesting because there is not that much parameters here, but it's local to the, in that case, it's local to the pixel processor node. This is something which you could use a lot in the FX map. Because in the FX map, you have a lot of parameters, so sometimes what you want to do, you want to set some values at the top of the parameters, and that you can reuse in the other parameters. It's maybe I'm going to do another live training on the FX map another day. So fast answer, yes, but it's useless. Okay, so
okay.
Don't do it.
Thanks.
So I remove that. So this was the introduction. So you see that you can really control tons of stuff with that. So right now, let's do what we really want to do, which is the kaleidoscope. So what you can keep for sure is you can remove what is at the bottom, this, and this, and just keep expose.
A quick question.
Go ahead.
I have an image that is not exactly squarish. It's 512 or 256. Can you crop in some way?
You cannot crop into if it's 512 by 256. That's fine. It's handled. It's not the best, but it has to be power of 2 on width and height.
Yes, but there is a stretching problem with the pixel processor.
Yes, maybe, yeah. Indeed. Yeah, it can be complicated. It can be complicated. Honestly, it works better with square images, for sure.
We'll see if I can crop it.
Yeah, if you can crop it fastly. Meanwhile, I'm going to use something that you cannot see because I made secretly something to remind me what we are going to do. Okay, so basically we are going to do different stuff. The first one is as we say, what we want to do is something like that. I don't need that. Is something where you have a parameter, and when you change the parameter, it just do this kaleidoscope effect. So this implies many different things. First, it implies, but the most important is rotation, of course. So in theory, what we want to do is to look at the image in the pixel processor. I'm going to show you what we're going to go inside and explain this. So don't be scared. We are going to detail one by one, but I just want to explain you what we're going to do. So basically, what we're going to do is to rotate the image, but make sure that it's instead of rotating completely, that it just rotates a slice. So meaning that it takes the value in just one part of like an apple pie, basically, that it just grab the value in this part, for example. And that's what we're going to do. So here I will need to convert the value to change the coordinates. As I say, I'm going to explain it after. Then, in order to rotate, what we have to do is convert the coordinates. Right now, we are in XY coordinates that are we call Cartesian. And in order to rotate it, what we are going to do is to convert it in what we call polar. which instead of taking x, y, it takes the length of a vector and the angle. I'm going to delve a bit into that. It will be a bit technical, but not that much. It's something that we are supposed to learn at like 13 years old, 14 years old. So if you were asking why in a class you were learning sinus, cosinus, etc., that's the day you will understand it. And then you see, so here I will calculate my angle, here I will calculate my length, here I will do the slice with the modulo value. I will explain what it is in case you can't remember. And then we are going to put everything together here. So let's go back to our training node and let's go back to our pixel processor. I'm still with you guys, it's okay? Seems so. So first thing you want to do, a bit of theory. You will love it. This. So not this. So first, as we tell you, we have to convert from xy value, which is Cartesian coordinate, to polar coordinates. And as you see here, don't worry, it will be fast. It's just define a point like this one with the length of the vector and here the angle relative to the 0 here. But in our case, as I say, we have just xy value for each point, and we extract it with the $pose node. So what you can do, hopefully, is there is a way to calculate that. So here, for example, when you have that, if you want to calculate, to convert it, what you can do is first calculate the length of the parameter. And to calculate, if you remember our friend Pythagore, or Pythagore, I don't know how to say in English, this guy is wise and he say, okay, to calculate this, you just have to take the x coordinate multiplied by the power of 2 of the x coordinate plus the power of 2 of the y coordinate, and you have to take the square root of this and it will give that. Actually, the formula is this one here. You know it, you have known it, and you maybe always ask me, it will be useless in my life, I will never use it. Yes, you will today, at least you haven't done this for everything. And this one is a bit more not complicated, it's easy to apply, as you will see, but you have to use the arctangent value of xy. We don't care what it is. Actually, if you look at a circle like that, it's basically the length of the pink part here between the angle. And it's really easy to calculate. What you have to retain is that this is what we have to calculate into Substance Designer. And that's what we're going to do now. A thing that you have to know about Substance Designer is that the coordinates, x and y, starts from the top left here. So here you have x in this direction, it's positive, and y, it's goes to the bottom, from top to the bottom. So the more you go to the bottom, the higher y will be. It's just for you to know. And we want to do rotation, but we want to do a rotation from the center. So instead of being like from 0 and 1 here, what we're going to do is to change the coordinate to make sure 0 is in the middle. Here it's -1. Here it's +1 on x, and on y, here you have 0, -1 at the top, and 1 at the bottom. And to do that, to change the coordinate, it's really easy. What you have to do, you just do a search and you type 1, and you see that you have everything to convert what you need. So what we want to do is to convert from 0, 1 to -1, 1. Is that clear so far? Not scared, not too much scared by the mathematics?
No, all good.
All good? Okay. So here what I did is really I changed the coordinates. Okay. So just to make sure and make it clear, especially if you want to come back to a graph, I really recommend you to use frames. So frame is just it's also available in a regular graph, but you see it's just make a group over, make a frame over the node you have selected. And this, what is cool is you can move everything together. So, and here I would say convert to -1, 0, 1. So it's just so once we are done, we know what we have done. So the first thing we want to do is to we are going to this I don't need right now. I'm going to remove and keep it from the end. So what we're going to calculate, we have x, y, we have converted it, and right now what we want to do, as we see here, is we want to calculate the angle, and we say the angle is the arctangent. So let's see that. So if you type here, you just say arc and magic. We already did for you. So right now there is a problem. You see, what's that? You see, it's not exactly the same color. Basically, this means that here it's expecting a float too. You see the same color. There is a color code for the node. If I try to plug it here, you see that it says, sorry, I have a float 1 here, and try to plug a float 2, so I have an error. So you don't want that. So we have seen that. What we need is to gather this together. So we are going to use a vector float 2, like that. We are going to put x and y and plug it here. So here we have just calculated the angle. So once again, I'm just checking that I'm not going too fast. I'm just going to add a frame again. I call angle value, like that. So for each pixel, grab the position, convert the XY position into another coordinate system, and calculate the angle compared to the 0, 0 point. So as we say, angle is the first part of the job. Now we have to calculate the length of the vector. So to calculate that, Pythagoras is our friend, so what you have to do is to use a multiplication one, like that. And we will need 2, so you do Control-D to duplicate it, like that. And I don't know if you know that, but if I click here and hold Control, I can plug it here and plug it here again. And you see you have another one. If I click somewhere else, it will disappear. So it saves you a few seconds. So Control, I hold, and that's it. So here, it means that for this x value, I have the power of 2 of this x value, and same here. You have to add this together. Once again, the formula I'm doing right now is this one. Square root of x power of 2 plus y power of 2. So that's just what I'm doing. So I have to add them together. And I want the square root of that, so SQ, give me square root. And that's it. Not that complicated. So I'm going to move that, and once again, I'm going to add a frame. That I called length. Okay. So let's see if it works well. Sorry. So right now, what I'm going to do is, before to go, we are going to see if the math are good. So what we did in theory is we convert it to one, we change the coordinate, we have the angle and the length, and right now we are going to convert it back to Cartesian, just to see if we are not that bad. So to do that, you are going to call a Cartesian node, like this one. And here, so theta, just to make sure it's the angle. Don't ask me why. Actually, you know what? I'm going just to inverse that. Just watch out when you move frames, not to stop it on another one, because sometimes it doesn't know what it has to grab, and sometimes a frame could steal nodes from another frame. Whatever. So right now, here we have the length that we have to plug into rho. It's a Greek reference, but it would have been maybe easier to say length. And here, theta is the angle. How's it going, guys? So what we have, oh, sorry, my mouse is like freaking out. So what we are doing, yeah, if you want to reframe something, that you just press F and go back to frame everything. So we have put it back in Cartesian, but what we have to do now is to make sure that we put it back again in the X, Y value, because if I use it like that with a sampler color, you can do it now. You can do, it's a mistake, but we can do it. And set as output node. I'm going to double click on that. You see that it's wonderful, but it gives me 4 cats, and 1 cat is more than enough. So why is it like that? It's because it's not the same coordinates, so it just duplicates the cats. So before to do that, what you can do is we're going to create it again. Here, add a swizzle node again, and we are going to reconvert into. So you use a swizzle float. I'm going to remove that. Control D to duplicate it. You know what? Before to duplicate, what I will do is just to you click on 1 and you say this one I want to get back to 0, 1. So I do like this, and I select the 2 of them and I do Control D. It's way faster. And now I just go to this swizzle float and I make sure that it's Y. Finally, I need again to gather these 2 channels together. So I need a vector float 2. And right now we have our cat. Once again, so far it's useless, but it means that this conversion is working well, which is good, meaning that I started from Cartesian, I converted it to polar value, and when I go back to Cartesian, it still works, so it means that the math here are good. Now we can start applying what we want, and we'll start with the rotation. So how can we do that? We have the angle here, so what can we do is just play with this value a bit. Another thing that I didn't mention with the angle is that in a Substance Designer, in the function graph, the angle works in radian. So as you know, everyone knows what is a radian. It's just a way to convert the math. So, sorry about that. Lots of friends, apparently. If you look at this cycle, you see that it's just a way to display the value. So you may be more familiar with degrees like that, or grades. But there is another one which is actually the most useful. I don't know why at school they teach the other one. It's the radian. Why is it the most useful? Because it's really related to the real length of the circle, which is based on p. Do we say p or pi? I don't know. P? Well, I would say p. I'm French. I'm allowed to do mistakes in English. So that's what we use actually. So you see that here, for example, the angle corresponds to p divided by 6 radian. So you see why it's really valuable. Here, for example, the angle is like half of p, and that's super useful because at the same time you have the angle in radian and this value is also the length of the what we call the arctangent, actually. Okay, so let's play with that. So now what we can do is create a float. And as I say, we don't want a value between 0 and 1. What we want, could be cool is to convert this into radiant. So to do that, you can say this so far. You can say terms. You know what? We can put it like that. So what you can do is just add node. Just plug that here. You just plug the result, the value of the angle here, and you plug it here. And nothing happened because the float is at 0. But right now, if I move that, you see that you are controlling the rotation of your stuff. Is that clear for you guys? Just checking.
Yeah, all good.
All good. I'm just checking everyone to make sure that no one is left behind. Cesar, you're good as well? Yeah, it seems to be good for most of you guys. Cool. So right now, this is already something cool because it means that you can control just with that the rotation. So far we are going to at the end we are going to expose this, but so far let's keep it to 0 just to make sure to control what we want. So here we are going to call this node. So much people.
I think Cesar needs some help.
Yeah. Too much love. It's difficult. And Cesar, let me see. How's it going, Cesar? It was good. It's good. Do you hear me, Cesar?
Yeah.
Okay.
I got lost here in the snuzzle floats, in the twizzle floats.
Okay, I think what you have to do here, you have some difference. Here you have to add these two nodes here.
Okay. Which ones are those?
If you press on spacebar and you type 1, it's this one.
Oh, okay.
It will convert the value.
0, 1.
Yeah, you need two. You need two of them, one for each. What you can do if you want to move stuff, you can do shift and move like that. You see, and replug wherever you want.
Oh. Okay, so this one's shift.
Yeah, perfect. Shift again. Okay, place them together. The angle is apparently right. The length is right. Then you do the contrary at the end. You see here? Yes, you did that. At the end, you see when you are here, you see that you have to go back to the Cartesian. So swizzle is fine, and this one you use the -1 to 0, 1. So once again, you do space and type 1, and they will appear because it's okay. You have it. Yeah, perfect. Okay. You can delete the float at the end, and you just have to replug back together with the vector float 2. No, this one you can with the vector float 2 right now and a sample color, and you do right click on the sample color and set as output node like this. Set as an output node here. Whoa! So you have a problem somewhere. Where is it? Let me check.
It's on this float. Oh no, this one's okay.
That I'm trying to see. This seems to be good. Cartesian angle xy. XY. I don't know why you could be wrong. Can you try to plug the angle directly in the Cartesian node? This one directly into the theta.
Yep.
Just this. Here, from here to the arctangent 2. Yeah. Can you plug it directly?
Directly,
Just
okay.
I don't think it's that. Okay, it's not that. There is something that is wrong somewhere. X, Y. I think it's something you plug maybe at the beginning. I suppose X, Y. Did you put? Yeah, that's good. At the bottom, can I see the lens? That's extremely weird. For the other person, it works well so far. If you see something that I didn't, just tell me.
Oh yeah, I know this one.
Aha, okay.
What is the input?
Okay, yeah, no, he just forgot to plug one.
Plug something.
Okay, so right now what you can do is
I'm sorry.
replug here this one for the rotation that you had. I think you did it already. Perfect. Okay, so we just created a rotation that we want to expose later. But right now, what we're going to do is maybe I think we did the most complex one, but I just this one is like you have to understand a bit. Do you know, guys, what is a modulo value?
Yeah.
More or less. Yeah. So yeah. I assume okay. So basically, it's the rest of the division. So what we're going to do is use this in a special case. Sorry, I don't see you. Where are you, guys? Okay, here. Okay. Okay, perfect. So what we're going to do is we have this. This I'm just going to call it. I add a frame again, just to call it general rotation, because you may want to control that at the end. Enter. Okay, like that. And now what we're going to do is between that, we are going still to play with the angle. But before that, we are going to do some stuff. So I'm going to make some space, like that. And here, what I have to do to create my kaleidoscope is first, I have to remember. So you need first a modulo node. Like that.
See.
I hear your mother this time.
Yeah, she's getting up to work.
And your dog, or a dog.
So the first thing we are going to do is first create a 2p, where we're going to multiply different stuff together. So we need a 2p value, which corresponds to full 360 degrees. So I need a float that I set to 2. I need the p value that we have here. I multiply them together. Like that. Okay. And what I'm going to plug right now is first the angle in the modulo, because that's what we are going to modulate actually, and we want the rest of that. And what we are going to do below is to define which section is going to be cut, what are going to be rotated again and again and again and again. Because right now what we do is we just say, you know what, catch the value in this, you know what, look here and take this value here and just sample it here. So we are going to say right now, just don't look here, but always look at the same time. Take the angle, but just always start from the same point. So to do that, I need to calculate this 2p. How do we say in English? Sorry, do we say p or pi?
It's pronounced as pi.
Pi, thanks. So I will say pi. For many years, to say height, I say height map. And everyone was laughing at me, so it was really hard for me. So I need another float that is be set to 1. Do you know what? No, delete it for now. What I'm going to do is, yes, a float, but just to show you. I have this float, and first and I'm going to multiply again. And I plug that here and here. So right now we'll take the value and we'll take the modulo if it was divided by that. So far it won't give me anything interesting, but let's use it anyway. So let's plug it in the angle. Actually here first, because it has to pass. So here, of course, it's broken.
Sorry, what is the second node on the first multiplication?
This one? It's a pi.
No, before the multiplication.
This one? This one?
Nope, before.
Before in the top, this one?
No, before in 2, 4.
Sorry, here the float. This is
here. Yes. Before that, this node.
There is nothing before. So this one. This is a modulo node. So basically, if you have a division, if you divide, for example, 6 by 4, it's the rest of the multiplication. So for example, 6 by 4, the rest will be, the modulo will be 2, because that's what rest to the division. Once you have, it's really the rest of a division. So for example, 6 modulo 2, there is no rest because it's 3 and with no rest behind. But if there is a rest in a multiplication, it will be that. And sometimes it's interesting to get just the rest, especially in case like what we are doing. So is it clear, more or less? I invite you to look in Wikipedia, and you will have the explanation. But it's really that, like, when you do a division, if it's not a perfect integer and you have a residue, that's what it's called, the modulo. That's what it calculates. So right now, if I move that a bit and don't leave it to 0, you see that we have what we want. You see, I just play with the value here. And the multiplication by 2 pi is to make sure that actually it could have worked this way. I could have used it like that and play a bit. But so far, you see that it's really hard to control. The number here doesn't correspond to the value we have here. So that's what we are going to fix right now. So
it was the pi I was looking for.
Ah, the pi. This one?
Yes.
Yeah, it's just, yeah, it's a 3.14 blah 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 blah. Okay, sorry about that. So yeah, as I say, so far I could hide this and say, okay, I just use the modulo and that and this one, and it works technically. I can just play, but once again, as we say, it's not really, it works, it's efficient, but it's not really useful this way. So we are going to make it in a way that is cleaner for the user. So first we are going to multiply by 2 pi, which corresponds, as we are in radian, it corresponds to a full 360 degrees value. And we are going, so if I do that once again and I plug it, it's a bit more interesting because when I have 1, here you see that you have the full image. And if I move, you see that if I put some value like 0.25, it gives me something cool. If I do 0.5, you see that it's just in the middle. So the fact by multiplying by that, it's a bit more understandable for the user. But once again, it would be better if it would be the contrary. If I type 2, that I have 2 divisions, 3 divisions. So it's easy. What you do is just create a new float that you set to 1. Do I have an invert now? No, okay. So I use a division 1, like that. And I do this way. So this one I'm going to set to 1 right now. And we are going to multiply here. I don't know why did I put, okay, it's here, I have a value, I have to put 0. Okay, so right now let's play with this value. If I put 1, you see that you have like nothing special. If you put 2, you see it's split in 2 parts, 3 parts, 4 parts. And you get the idea, you can go like 20 parts. And right now, it's way more understandable for your user. This is something that was not mandatory for the not to work, but as you do, finally, when you do a substance, you do it for someone else. It's better to make it like understandable. So all this, I'm going to clean a bit like that, like this. I'm going to put that. So that's it for the construction. Now what we're going to expose, I'm going to call this add a frame, and I'm going to call kaleidoscope. Like that, and I'm going to move it a bit. Now what we want to do is to give some control because we build that, and we are just going, in order to finish this, to expose some value. Just let me give, so I don't know if I have some question here. No. No, do you have any questions so far? Is it good?
I have a quick question. Why are you using float instead of integer if you're trying to make like solid number of segments?
Good question. Because first, maybe the user wants not to use. You can do like that if you want. Actually, maybe the user doesn't want integer. Maybe you want 4.5, and it works. You see. So it's to give the ability. And second is because even you cannot mix integer and float directly, meaning I will have to convert to float, then to integer. That said, if you would like, I'm going to show you when we expose, you can force the parameter to be integer, like to be round number when you use it. But once again, as everything is float, it has to work together. You cannot mix float and integer, it won't work. And you have,
Vinny,
for example, yeah?
I got a message like 10 minutes ago from some people at the Sony studio. They just said that they couldn't see your screen anymore. So, but
They cannot see my screen anymore?
yeah, but we can see it fine here.
Okay, I think it's good now. Oh. Okay, that's bad. So what I'm going to explain now what I've done, maybe in case I missed. Sorry about that, because it was, I think it's when I was explaining what was happening to Cesar. So basically what I did, this didn't change. I had the general rotation, but as you see this part, and what I did is basically building the kaleidoscope part here. So in order to do that, what I used is a modulo. I first add a value like this. Let's say I start just with that, with this value. And it's enough to make it work in the sense of, you see that you have a modulo effect, which is working fine. And the rest of the math here is just to make it understandable by user. Basically what I did, I just made a reference to the of 2 pi, which is a 360 degrees here. And then I first said I could multiply it this way and just use that, like forgetting the 1 divided by. So just use that. But once again, it's not the most... it works, no problem with that, but it's not really useful. We can say, okay, if I put 0.5, it's 2 parts. If I put 0.333, it will be 3 parts. But once again, for the user, it's maybe not the best. So what I did is a division. So what I said is I'm going to divide 1 like that. And now, if I put 1 here, it's fine. And right now, it's way more useful for the user because this is what we're going to expose. If I put 2, you see that it gives 2 parts, 3 parts. Yeah, I think hopefully that's the only part you missed, except the explanation of here, but it was stuff that we have done. So right now we have this kaleidoscope. In case if you I think it's Kyle. If the guy can contact you to tell you if everything is fine for them. But I think that's the only part that they may have missed. Actually, the audience may have missed. So yeah, here right now it's good. So once again, now that we have that, what we want to do is to make sure to expose these 2 values. This is controlling the general rotation of the image, so you can choose what you want to expose to, which part of your cat you want to expose. And once again, I think you want to turn it to radiant. So to do that, you can take it. You type degree. So right now, when it's between 0 to 1, it's in turns. So we are going to transform the turns to degrees like that, and then you have a degree to gradient to radiant, sorry, like that. So now we have this between 0 and 1, and it controls the value like a 3 full turnover between 0 and 1. So you can control which part of your cat you want. Okay, so now what we want to do is to create two attributes to control this and that. So that's what we're going to do now. So in order to do that, you are going to create 2 get floats like this, one here, and you duplicate it, and one here. You are going to go back to your main graph, double-click on an empty space. So I don't need this distortion amount anymore. And we're going to create 2. So I click twice on it to create 2 input floats. One, I will call it general rotation. Oops. Let's make it big. Still with me, guys? Yeah, apparently. I give a label just to make sure that it's well displayed for the user. And the second one, so general rotation between 0 and 1. And the second one, I will call it slices, which is actually the slices you want to use. Okay, so I have these 2, and it's 2 float ones. And this one, actually, you see the default will be 1, just 1. And I will put the minimum to 1 and the maximum to, for example, 20. But it could be more if the user double-click on it, but let's set it this way. And this one between, let's put the default at 0, and let's set it between 0 to 1, which will be a full turn, so it's perfect. And now we go back into the pixel processor. Maybe I wait 2 seconds that you are ready. And I guess you may have guessed what we are going to do. With this one, we're going to give the slice variable value, and we are going to replace this. You can delete that, the float one, which was just to build the node. And here, for this one, we are going to give the general rotation value variable, and you plug it instead of that, and you delete this. And that's it. You have your main graph here. Here I could add just a frame and call it re-conversion. It's almost religious. So let's summarize. First, we grab the position for each pixel. What we did is we grab the position, we convert it to another referential to make sure it happened in the middle. We calculate the length, we calculate the angle, and we added displacement for the rotation, and we added a way to slice the image in different parts with that. Then we can add a general rotation on it, and finally we reconvert everything in the proper Substance Designer coordinate, which are in 0, 1. Now if you go back here, do I need that? No. If you go back here and double click here, you see that you have your general rotation that you can choose for the image, and you have the slice value. Someone loves me again. And you have your general value. So what you can do after to make it perfect, it's not really the scope, but you can add an input color node, and you replace here, and you can just export your create a substance from it, and when the user will use it, he will be able to select this. The only thing that you will have to do before to do that is to make sure that the size is relative to parent and set to 0. So you don't have any problem of sizing if it's used somewhere else. So let me check. Right now it's not the case, you see, so I will have to say relative to parent like that. It will be fine. So by default in the parent, the default size in Substance Designer is 256. Not a big deal, it's just for you to see, but that's something that many people are forgetting. So I think that's it. So guys, if you have questions, first, do you think it has been useful for you? You understand more the pixel processor node?
No. Well, just one, but not about the pixel processor. How do I get to add the input parameters? Well, the little tabs.
To add an input parameter, so first, when you are in the graph mode, you just double-click on the graph, and here you can add a parameter. Okay.
Which one? On this one, or?
Let me see your screen. Who is speaking? Sorry, it's Marcello?
No, Cesar.
Okay. So let me see where you are. Yeah, so when you are here, double-click on an empty space.
Okay.
Yeah, and you see on your right, input parameters, you have a plus. Click on the plus. Okay, you created it. So just give a name here, a clearer name. Perfect. And exactly. So once you have created them, you go back to your pixel processor. So you can click on it, or yes, or by the thumbnails. And now in the list, you will have the parameters appearing.
Okay, thank you. Right.
Any other question, guys? Thanks, Bjorn.
Can we create custom functions for the pixel processor node?
Yeah, actually, that's what we did during 1 hour. Actually, this, for example, is a function. And for example, if you want to reuse, I'm going to show you something which could be interesting for some of you guys. What I like to do is to create, for example, I invite you to create a Substance package somewhere, like an USBS, where you will store all your interesting functions. So for example, let's say, you know what, this is really interesting for me. What you can do is do a right-click, select it, for example, right-click on it, and say, I want to create a graph from that. So when you do that, it will say new graph, and I say, I will call it length, and this one is not a good example because it's not perfect. Length, angle. So you see it creates a graph here, and you just have to re-put the inputs, replug the inputs, and this is something that you can reuse. Yeah, sure.
For the slice parameter, did you use an integer and cast in a float?
I just used the integer. Let me check. Where is it?
You can use directly an integer.
The thing is, as I explained, I'm just checking. Okay, here. Here, for example, if you use an integer, if I go inside, when you do a graph, you cannot mix easily integer and not. This is something that you could do. For example, what I could have done is say, you know what, I absolutely want an integer, so there is different ways to do that. If I go here, I can go to my slice parameter, and in the step, I can say I want step of 1, like that. So what it will do is when it's exposed
to exactly one at a time.
So if I'm here and I expose, you see that right now the slice is 1, 2, 3, 4, and I think 4.5. It's feasible, but it has to be done by hand. If you really want to say, you know what, I just want an integer, what you could do, what you could do is create, for example, a value, and I say, you know what, it's an integer that I want, integer 1, and I call it slice int, I will call it so far, so we know. And you can go into your pixel processor node.
I think there is a cast node.
Exactly. So where is it? It's slice here. So I say get integer, like that, and I catch it, and I use two floats. Like that. It's, as I said, it's really, in our case, it's not a big deal because it could be cool to have like value. But right now, that's what it does. So right now, if I go back here, I go launch here, the slice doesn't controlling anything anymore, and it's this which is controlling what you want. And you see here, it's a pure integer that we convert. So it's, I don't know if it's what you want, it's feasible. You just want to avoid the 0 because you see it breaks everything, but you can start at 1. Change the minimum value here.
Set the min at 1.
Exactly. And say the maximum to 30, for example. Just, if you have any other question, don't hesitate. I'm just reading the explanation because I admit it's my first broadcast and I'm not used to read everything. Crash. But it was a Chrome crash. Yeah, spacebar, as you say, it has been asked. It allows you to access everything. It's available in regular graph as well. Your cat, your cat looks sad. Yeah, so I said 1 hour and a half, and I think we are pretty good. Thanks. Just is there any other question that you want to ask, guys?
I've got something quickly.
Yeah.
With this, because so now that I've got an input and output set here,
Yeah.
if I want to say put that on Substance share, that will work fine, right?
Yeah, you have some stuff that you have to check when you put on Substance share. Is just make sure that the output size is relative to parent always, and with no multiplicator. That's one of the things. Make sure also that you didn't embed any images. That's something that some people forget, except if it's yours and if it's useful for your graph. Except this, I think it would be good, and make sure also that the input or output has a clear name if it's necessary. It depends what you want to do with it, but generally we want to make sure that they have a clear name. In this case, input output is fine because it's a filter, so it's not really a generator of material. But yeah, what you can do when you create a new one, you have some option like this. If you use a painter filter, I think you are pretty good to go, because you see, if I use that, just to see, yeah, you have primary input, primary output. Here, for example, the size is not good relative to parent, and you are good to go, and you can do your math in the middle. What you may want to change is replace that by an input color, in our case. Is that clear?
Yeah, sweet, cheers.
Cool.
And sorry, I think you can also check. There is on Substance share a page for with all this information, right?
Sorry, what about Substance share? Sorry.
I would check if a substance is okay to put in Substance share.
Yeah. You can put for people who don't know Substance share, I'm going to show what it is, maybe, because we are speaking about it, and it's a super awesome service. Actually, it's a community-based sharing stuff where you can really put brushes for Substance Painter, effects. Many stuff, images. There is tons of stuff. There is more than 1,001. For example, this one, you see, it's one I made a long time ago, which is based on pixel processor. So you can really put a lot of stuff and share for free, and it's free to use also at home or for commercial use. So anything you will use it, you can use it to do whatever you want. And it works pretty well. If you want more high quality content, we have the store right now, but it's another concept. It's really a curated content that we sell, and it's super high quality. There is tons of crazy stuff on it. So I invite you, especially if you're a studio or someone who really wants to do high quality stuff, but that doesn't necessarily have the resources to do it by himself. It could be, sorry, with the streaming at the same time, it's a bit long. And meanwhile, also, if you are really interested to know about pixel processor, on my website, cgvini.com, if you go in the tutorial category, I made quite a lot of tutorial which are about, most of them are about the pixel processor, so it may interest you. And let's see if Substancer accepts to load. Yeah, it starts to load, but as I said, as I'm streaming at the same time, it's a bit slow. But you have like really high quality content on it. You see, if you are doing characters, we do mood pack. There is a game texture on it, so that's something that could interest you as well. Any other question, guys?
No, thank you.
Thanks to you guys. I'm going to put back my face, maybe. Not that I'm really beautiful, but okay. So I think that's it. I say 1 hour and a half. It's exactly 1 hour and a half. I hope it's way clearer for you guys, that you have understood how it works, basically. So this was just an example. I invite you to play with it, and just don't forget. I would say that. If you think really that the pixel processor node work for each pixel, if you say for each pixel do that, it will help you to really understand what it does. And once again, the $pose built-in variable is really useful, and the sampler color or sampler grayscale. That's something that really helps, and then you can play around that and build crazy stuff. So thanks for watching, and see you soon.
Bye, Billy.
Bye.
Thank you. Bye.
Bye bye.
Cheers, Vinny. Bye.